I'm Ashish Sarbari, and I work for Imagination Technologies. And I would like to go back to the question I asked Sergio, but it's also addressed to the other people on the panel. What do we do about over-constraints? Treat this question as not specifically related to formal, but in general to all forms of verification.
Okay, so Sergio, do you want to go first?
So Sergio Marchese from OneSpin Solutions. So you're right, constraints are one of the main risks in formal verification, because if you over-constrain things, you can simply miss functionality in your verification. So we have a number of products and methodology to tackle this. For instance, Quantify will analyze your constraints and find if you have that code because of your constraints. So it actually distinguishes between that code, because it's that code within the design, or code, RTL code that becomes that because of the constraints. And that obviously points out to code that you shouldn't be that probably. And then it can point to over-constraining issues. And on the methodology side, for instance, one thing is to develop the constraints as an interface and run them with the system simulation, so to get more confidence in the correctness of your constraints. So typically, ideally, you have constraints at the interface of your module, and you can kind of validate them also with your higher level simulations.
Yeah, I think the answer could be divided into two. One is over-constrained from a functional perspective, and I think there you really need to understand the specification of your design to figure out whether you over-constrain the functionality or not. But from a verification point of view, I think as I described, in the presentation before the break, there are ways, we have one way, other people have other ways to apply formal methodology to figure out if you are not able to reach all of the state space, not just the statements, but all of the state space of the design, specifically because of over-constraining. Then you have to decide, is this over-constraining appropriate or not appropriate, so that's more of a judgment.
Okay, and what about other UVM type verification? The problem is the same, right? It applies to dynamic simulation-based verification as well. I mean, are there solutions out there that...
So this is applying the same problem, but in the simulation space rather than a formal space.
So you're talking about constraints, yeah? Yeah.
Is your simulation over constrained? I think is the question.
Right. So I actually.
Could you just say?
Spindesh Patel from Synopsys. Constraints actually for us were a dark art at Springsoft, but once we got closer to the simulator, now we have access to some simulation technologies. At least we sit next to them. There's a lot of cool constraint debug and analysis capability that, let's say, VCS provides, and I'm sure the other simulators provide. And so a lot of work has gone into attaching, let's say, Verdi as a front end to these kind of constraint manipulation capabilities that the simulator natively has, system verilog test bench constraints.
Okay. Anyone else want to speak to that?
So you're talking about, yeah, it's Mark Olin from Mentor. I know it's for the online people as well, right? So got it. You're talking about how to determine whether you're over or under constraining in a dynamic simulation environment. So there are tools out there that will help you do that type of analysis. And we talked about earlier using the graph-based technique with the embedded constraints. And that comes with a built-in constraint exploring capability that actually allows you to enumerate how large or not so large your test space is. And it's actually very visual as well. In our experience, we often have users of that technology that are able to find bugs in their verification processes before they even run a second of simulation just by inspection. So that is a technology that's available. If you Google intelligent test bench automation, you'll find more on that.
Okay, and that technology is specific for test benches and dynamic simulation.
That is dynamic simulation, right? Right. I took it that was the context you were asking.
Yes, yes.
Okay.
Okay, anyone else? Okay, we'll move to our next question. I know there were two people keen to...
Hi, my name is Aditya Pagonda. I work for Broadcom. So my question is somewhat related and not related. It's basically, if we're talking of formal verification here, we say we need to constrain things along with your property checks so that you kind of tell what kind of design scenarios you expect and then make sure that the properties hold true. But the problem I have is I want to use formal. I have these checks which are basically used in dynamic simulation to make sure the design is doing the right thing. But I would also like to use the constraints which are already been defined in your UVM test benches in terms of sequence items or sequences. So there's a lot of inherent constraints that have already been written. Is there somehow I could reuse these constraints into formal space?
So I guess the question is reuse from dynamic into formal, both constraints and assertions as properties.
Yes.
Yeah. Okay. So over there, Jael, do you want to start on that one? No.
So I'll start. I can start. So this is Oz from Jasper, and the answer is that I really don't know because I haven't seen your constraint, but in general, I would say that the answer should be yes. You should be able to take the constraints that you have from different environment. I wouldn't claim here that it's automatically going to apply. Somebody has to look at it and tell what it is. But in general, yes, I don't see a reason why not.
You mean straight out of the box? I mean, I could just use a sequence item written in UVM which says constraint.
So using the word just use is dangerous.
Okay.
As I said, you got to take a look at what you have. Jumping into using formal is now becoming very much easier to use, widely applicable, widely usable. But it's not like riding a bicycle to the store to pick up a quart of milk. That's not the way to think about it. If you're interested in formal, the reason to be interested in formal is because on a period of time, it's going to benefit you. It is not a casual sex. It's something that you need to make a commitment to. Excuse my French. It's a commitment that you need to make, and it should be motivated by a real problem, by something that is specific that you have, something, real verification issue that you have. That's my view. Martin is hiding under the chair.
As long as it's safe to have done, it's fine.
This is Sergio from OneSpin. So I agree with those, and I agree with you on the specific question that it should be possible to use this. I can tell you today it's not possible with OneSpin, and I don't think it's possible with any other formal tool, to be honest. But I see your point. What I can, kind of be a bit controversial, flip the question maybe a bit. It's like maybe you could write things in a more general way, that such that also formal tool can swallow them. So yeah, this is but to answer your question, we cannot do it, and I doubt anyone else can do it, and I doubt it's going to come available anytime soon.
So I just wanted to add one observation related to your question. I don't think you can actually directly process any of the UVM constraints into formal tools. I think that's because the formal tools or the system Verilog LRM for assertions has enforced everything to be synthesizable. And I think whenever that happened, for the right reasons or the wrong reasons, has now made life very hard. And I think the fundamental problem is that none of these forms of verification are actually used in silos, and we want a continuous integration of all verification methodologies. And we are up against a wall because we have this problem that we have lots of UVM constraints written down for a test bench. The test bench may not necessarily have the checkers, or it may take a long while to actually build the checkers, and we could write assertions quickly. But sorry, no, we can't, because we can't actually reuse any of the UVM constraints. It adds a lot more work. So I'm actually surprised that both Jasper and the OneSpin guys believe that we could actually use the UVM constraints directly in the formal environment as of now.
I didn't say that.
Okay, so we can't. So you agree we can't actually use it?
I think they didn't say the claim. They're certainly not casually anyway.
Fair enough, yeah.
According to us.
Yeah.
So
I'm not going into whether casual is good or bad, but what we definitely are missing here is an Accelera initiative on System Verilog, LRM, and all the tool vendors putting their hands together and saying, let's make it work across the spectrum of verification technologies. There's a lot more formal is great, UVM is great type discussions going on, but it's counterproductive for verification.
I think that's actually genuinely a very good point. Be able to use UVM into yeah. Okay. Scott, do you want to go next?
Yep, so I'm Scott Kennedy from ARM in Cambridge. I work in the processor division. So just now we have very good reuse of test benches from one project onto the next. We use our own internal lightweight System Verilog methodology. We keep hearing about UVM all the time, and there's various degrees of UVM adoption within ARM. But if I'm going to my project manager or my engineering manager and saying I want time to redevelop test benches to use UVM, what are the main advantages? Performance is key for us. We want to get through as many cycles per second, blah, blah, blah. So any more heavyweight methodology might actually cause us a performance hit. So that's something we're very concerned about. So what would be the advice on how we should adopt UVM in terms of avoiding it being a very heavyweight methodology?
I'm sorry, so what is the problem that you're trying to solve?
So the problem is that we view that, or potentially UVM, it's a very heavyweight methodology.
No, but that's the problem that you might have if you adopted UVM.
Yes.
That's the problem that you're trying to solve by adopting UVM.
Well, that's what I want to understand, right? So we keep hearing from the industry, I think someone said earlier, that everyone will move to UVM. My question would be, why? Why should I move?
But I'm asking you specifically, what problem are you experiencing today with your current methodology? It sounds like it's lightweight. You like it. You seem keen on it.
Yep.
It maybe makes you coffee. I don't know. Maybe that's coffee. UVM doesn't make coffee either. So
I would say we don't necessarily suffer with the methodology we've got. We do like it, right?
Okay.
What we're trying to see is there something we're missing? Is there a compelling reason that we should?
So, for example, you feel like you can, if you're debugging through the test bench, you feel like you can debug properly without needing to have a UVM-aware debug, for example. I'm asking. I mean, in my previous consulting work, I always would ask, why? We're going to switch to UVM. Why? Why? I mean, I'm on the UVM committee. I kind of like it, but why?
See, I guess that's my point.
That's kind of a weird question, I think.
At the moment, we can't see a compelling reason necessarily to move.
Sure.
So I guess that makes the question as to why the industry is moving over to UVM.
No. So the comment in the audience was, it makes the, why should the industry move if individual people decide they should move? Actually, I'm sorry, I didn't see you over there. I'm just not paying attention. But I always ask people when I'm consulting or when I used to be consulting, why, just because everyone else is doing it doesn't mean it's right for you. You should evaluate for you, and for some people it is quite useful, but for some people it is not.
Yep.
So it's okay for it not to be useful for you, and if you understand why, that's okay. But I don't know, John, if you have.
So I'll give you a couple of reasons why you might want to move to UVM. One is next time you try and hire somebody into your team who's already some way up the skills ladder, there's much more chance that they'll be skilled in UVM than in your particular in-house methodology.
Yep.
Another reason is when you try and integrate verification IP, maybe from, I don't know, in the case of ARM, I don't know, because maybe it doesn't apply to you guys. But in general, if you were trying to integrate verification IP from other suppliers that was already written in UVM, then the integration task would be simpler.
Yep.
So there's two reasons. But having said that, I do echo JL's thoughts. I mean, there are folks out there using all kinds of verification methodologies, legacy methodologies, in-house methodologies, and they work. So you won't move until there's a compelling reason.
Yeah, I would agree with John as well. I think it's for industrial reasons, but about the industry, where if the IP is available and trained people are available. You may also have the recruitment problem. I know some people go for jobs just because they want an UVM, so that might be another issue.
Okay, thanks. So I'll put in a plug for the other side, why you would, Vindesh Patel from Synopsys. So why you would want to, one key reason I think is because it's a standard, there's
there is supporting tools and sort of an ecosystem built around it that you can leverage. It's not just the human resource. There are other resources as well. And for example, again, looking at the debug-centric point of view, which is where I come from, in fact, the Mentor and Cadence also do this, is to leverage some of the UVM hooks to record transactional data. So this is something, if you end up using your own library, let's say, or methodology, you would have to build that yourself.
Can I just say, as somebody who doesn't represent a particular EDA vendor, John Ainsley from Doulos, we are seeing across all the system Verilog simulators more support for UVM-aware debug, UVM-aware, just driving the simulator, and UVM-aware editing environments.
I was just going to point out there is actually one other standard that might be applicable to you, which is the Accelerum, the multi-language standard that's being developed on Accelerum. Because the idea of that is that you might have different, even within the same language, you might have a different methodology. And you might want to have a way to communicate between either different methodologies in the same language or in a different language. In which case, that standard might be a way that helps you guys out because you have something that you've written in your standard and you want to take advantage of things in other standards. And if the multi-language is capable, then you could actually plug them together and still use it once that's complete.
This is Oz. I think I'd like to, I'm not selling any UVM here, but I'd like to applaud your question, which was, my understanding is, what questions should I be asking that I'm not asking? What don't I know? I think it's very useful once in a while for anybody to just surface and ask themselves, what am I not seeing? And maybe the question should be to the audience. Which ones of you have switched to UVM? Why did you switch? And what did you get out of it? Not everybody at the same time.
So, did you want to speak to UVM? Okay.
Hi, this is Dave Head from Altera. We switched to UVM because we were starting up a new group with no legacy test benches, and we wanted to see if it was the right way to go. We're sticking with it at the moment. I'm not sure it's the right way to go. It's a lot bigger than you probably think it is. It uses a lot more simulator resource than you probably think it will. If you've got something that exists and works for you, it's probably not the thing to move to. If you're in a startup and starting something from scratch, it probably is the way to go at the moment.
Thank you. That's a very good answer, actually. So, like a self-help group, isn't it? It's UVM users anonymous. I am a UVM user.
Can I ask a question? I have a question for JL. So I really enjoyed your presentation. I think it's nice and important to pose these questions, fundamental questions. And I agree with 99%, 98%. 1% is the same as him. And then at the end, you were talking about the specific thing, prioritizing, you know. You said if everything is high priority, then nothing, you know, you don't prioritize. And in my experience, actually, I've seen that this is another common thing that sometimes I think it's good to challenge. It's kind of everyone accepts you need to prioritize your tasks. But I've seen in some real projects that sometimes this is counterproductive, where you actually want to tackle all your things, not bother about going to the ASO to understand what is high priority and what is low priority. And yes, most of the time you have to prioritize, but sometimes maybe not.
So your statement is that prioritization sometimes is not a good idea, or
in terms of verification tasks,
or that you don't necessarily want to spend a lot of time on it.
Yeah.
Because I'll tell you this for sure. When you start to do your tasks, you have immediately prioritized them. So you can't not prioritize them because you're going to pick one. So the question is, how much time do you need to spend to do the prioritization? Now, sometimes,
I agree.
And so you could argue that, well, within a general area, maybe it's not important because all these tasks have relatively the same. But then I'll pick one, and as soon as you do, you've selected, but you didn't spend a lot of time thinking about it.
Yeah, I mean, also I was perhaps referring more to IP level verification, and sometimes I see some effort spent, okay, this we verify later, is not so important, or this, actually I see effort spent on trying to understand, and I think sometimes this is actually wasted. I've seen at least in one project. And yeah, I just wanted to contribute this, maybe add one more controversial point.
Oh, sure.
I think we're going to move back to the audience before the panel implodes on itself. Okay.
Chris Higgs from Potential Ventures. Question about UVM. Sorry. So it's Chris Higgs from Potential Ventures. UVM already seems quite dated. The fact that you have to write a lot of boilerplate or have code generators suggests that there are flaws in the underlying language itself. Is the drive to adopt UVM hampering innovation in the industry, and is that as good as it's going to get?
No. John Ainsley from Delos. No, it doesn't hamper anything because it's not about innovation. UVM is a standard. Standardization is often misunderstood. Unfortunately, it's sometimes misunderstood by standardization groups, which doesn't help. Standards don't exist to innovate, primarily. Innovation is going on alive and well. Innovation is going on within the standards group, which isn't necessarily so healthy. But I completely accept that there are better ways of doing verification than UVM. And standards cross the boundary between business issues and technical issues. Standards need to represent a compromise and a consensus in order to get a whole bunch of organizations to work together. So I would say to anyone who's innovating, keep right on innovating and keep right on trying to compete in the market and try to win customers over to your particular way of doing things. And if you're successful, then standardization will follow. And some of your ideas will influence whatever's going on within the standards groups.
That's a very good point, John. I agree. I think that's a great point.
Okay. Anyone else?
Yeah, it's Mark from Mentor. I'll just make a quick comment. I know that we all are, I'm confident we all up here and others are continuing to invest heavily in innovation, and whether the standards slow us down or not, well, what it does is it probably gives us an additional dimension of something to think about so that we can make sure that our innovation is consistent with the standard or built in the proper environment. But if we don't do that, then we don't actually get the adoption and the ready adoption by the users. And that in of itself would hamper innovation as well. So there's sort of a catch-22. If we can build our innovation consistent with the standards rather than going out and doing something that's totally custom and requires you to rebuild something from scratch, then we enable you to adopt it earlier, and therefore we can develop it further.
Mike Bartley, I would agree with that as well, because if you're trying to innovate and you can see that UVM's got 80% of the market, then you innovate around UVM because you know you've got a ready-made marketplace for your innovation rather than anything else.
This is always, I've spent a lot of time in standards in the past, but I will be the first one to tell you, standards are not law. It's okay to violate them. And I think people violate them all the time, so long as you violate them for the right reason. And the right reason is bring value to customer problems. Now, it would be stupid, and I use this word very cautiously, to go ahead and develop a whole new different language today for hardware description, for example. At the same time, if you have extensions to System Verilog that are absolutely necessary in order to capture security verification that customer demand from you, go ahead and do it. Innovation is alive and well. It's not going to stop because of the standard. It's built on top of standards. So I'm not concerned about that. Okay. I think that there is a concern that maybe some, organizations are spending undue time in talking about some political issues and whatnot. But you know what? Who cares?
Okay, I think we'll move to our next question.
Hi, my name is Adrian. I'm a verification engineer at ARM. My question is it is a good approach to make the driving side of our verification environment aware of the coverage model and make that 5% coverage closure easier by employing this in an environment.
So that's automated coverage closure, effectively. Yeah?
Yes.
Yeah, automated coverage closure. Oh. Oz can't resist it.
This is Oz. Yes, especially if you take the time to understand your verification goals rather than just bluntly and with a brute force decide that you have this broad coverage target, which is 100% of something, lines, branches, whatever, expression, what have you. If you really take the time to understand what is the functional areas and the functional coverage that you're trying to reach, I would say it's worthwhile to invest in tracking, invest in measurement. People usually improve what they measure. Nothing else improves. If you don't measure it, it doesn't improve. So if you want to improve your verification closure, start measuring it right now.
Yeah, this is Mark Olin from Metagraphics. So in terms of getting that last 5% of coverage, there are a couple of things about that. First of all, so that's a separate or different question from another important one, which is how do I know I'm actually specifying the right things to cover in the first place? But what your question sounds like is if I decide what I want to cover and I write a coverage model for that, then, as we've seen, it's typical that, especially in dynamic simulation, you'll have an asymptotic approach to your coverage, but those last few percentage points are pretty tough to achieve. And again, there are measuring, of course, is the first step to getting there, and one thing you can do is use post-simulation techniques to measure your coverage and then to go back after simulation and use some of that information to tweak your constraints and to help give a little bit of a boost to a constrained random test environment. Another thing you can do is raise the level, we talked about earlier this morning, raise the level of abstraction of describing your test space using a declarative technique like we've talked about, the graph-based technique, and that will get you to your coverage goal and get you that last 5% very quickly. That though opens up the next question, which is once I get to my coverage goal, now I have to look at the harder question, which is did I specify the right coverage goals in the first place? What am I missing? And they're both interesting questions. But if you've got coverage goals and you can't get to closure, then you need to look at the graph-based technique and see how that'll get you there. And by the way, it's consistent with the UVM environment as well, so it doesn't. Thanks.
Just one other comment. This is Oz. Because you're from ARM, I wanted to plug ARM here. We just had the Jasper user group, and Laurent Arditi from ARM presented some of his measurements for success or for ROI. And it's interesting that, he talked about coverage as well, but he also discussed other measurements. For example, he talked about finding more bugs, finding the bugs earlier, and he tracked these things. He measures them, and he improves them. Other criteria that he used was code churn. How often and how frequently and how much did the code change from design to design as a way to measure the improvement in his verification technology. So you have many, many approaches there, but measure what you want to improve.
Okay, thank you. Anyone else? I think we're going to move to probably our last question. Please.
Okay, I'd like to put this to the EDA vendor. Is this close enough?
Yeah. You have to say your name.
Okay, I'm Krishna Priya from Infineon, and I'm a design and verification engineer. And from the EDA point of view, what would be your biggest concern right now from what your customers have given you the feedback or what you're working on? What is the biggest concern among the EDA companies? Well, it can be your biggest challenge that you're trying to solve or what the biggest concern your customers have given you, or if I don't know if it's very sensitive information, but I'd just like to know what.
I think we're under NDA, that one. Or
well, from at least our experience, we see a lot into leveraging IP level work at SoC level, which comes to also the presentation we had, and also in the mixed signal domain, which still it's kind of a little bit outside the application of formal, but it does cause a lot of concern to customers, and they ask us, to do something formal in that world. So I think that's an interesting challenge for us.
So JL from Cadence. So I'm new to Cadence, so I'm not familiar with all the challenges that are facing Cadence, but I would say areas that I'm involved in that people are looking at, how can they take advantage of design and verification IP to speed up? Can that be useful in the development of their SoCs? So if you're, do you want to have to build the whole thing from scratch, or do you want to bring in something? Will it be the correct level of quality in order to help you out? These are challenges I think people are trying to assemble these things quickly, and so can they do it in-house? Do they have to bring from outside? And what are the quality metrics associated with that? And what good of a job how much will that help them? So that's a problem that I've seen since I've been at Cadence.
So this is Oz. I'll mention a couple of areas that we hear from customers that we are addressing, and at least one that we don't address. Low power verification, especially multi-clock domain, variable voltage, variable clock, security path verification. Another one is sequential equivalence checking especially for power-related optimization or other ECOs, post-silicon debugging, finding bugs post-silicon. There are others. This is not necessarily in the priority. One area that we hear that we're not addressing is software verification.
What about safety verification? Safety verification, has it been a concern among any of your customers?
We are hearing a little bit about that, but more about security in the sense of data security, sanctity and leakage from encryption keys and other types of, not so much maybe automotive-related safety that I think you may be referring to. We have not heard that much until yesterday.
So I'll mention two areas that I'm closely associated with. I think people, Bindesh Patel, Synopsys, two areas that I'm directly dealing with. I think there are a lot of challenges for the big vendors. You get presented with so many challenges, but two areas I focus on. One is related to the safety aspect. I think we've got some unique technologies ourselves around this as far as coverage with our Certitude tool. I think that's perhaps the direction that Certitude will evolve into, more of a specialized application area, at least some aspects of it to the safety critical area. The other challenge that we consistently face is the amount of data. So data is something that the simulator requires, memory, disk space, but also when you record data, you store data during your verification or whatever tool you're running. And once it's there, so you have to store it, you have to pass it, you have to share it. And then once it's there, in the end, a human being has to make sense of it. And for me, that's a very interesting challenge.
Yeah, it's Mark from Mentor. Probably our biggest challenge right now, it's reasonably broad in nature, but it's it's developing verification technology that can traverse all of the different platforms that not only simulation, formal, and emulation, but going into FPGA prototyping, post-silicon validation, even all the way into production and field returns. And then we're also working with customers who are wanting to verify earlier at higher levels of abstraction. And so as their design abstractions rise, they want to do earlier verification as well. So that's a challenge as we're looking into more behavioral level verification and keeping up with those changes in design as well.
Okay, that brings us to the end. For the sake of the webinar, because they can't win the prizes, we'll bring things to a close. We'll just say thank you very much to our sponsors, Cadence, Mentor, Synopsys, Jasper, Doulos, and OneSpin, who are on the stage. Obviously, Real Intent have already gone, Aldec and Greco as well, are silver sponsors. Thank you very much to our speakers who are still probably in the audience, and thank you for coming. And thank you for Lisa and Sarah for doing all the organisation. So thank you.